morning, class, and welcome to another day of chemistry. I hope you all are well. Today we're going to be learning something very exciting that I really like, a topic that I've learned and studied a lot. And it's very important because we're bringing up old topics and lessons and incorporating them into today's lesson. And I advise you all pay attention because it is very important for the class and it lays down the groundwork for future chemistry lessons that we're going to be going over. That's why it's so important. So today we're going to be learning about a new topic, and at the end of class we're going to be doing a little project, group work, so I hope you all will enjoy that. I think it's very fun. I think you'll like it. Chemistry books. Please turn to page 200 in your chemistry textbook, and the title of the chapter is The Atomic Theory. Now, for those of you who may have never heard of this, the atomic theory talks about many things, but it's one main topic. Who wants to take a shot in the dark at what the topic is? That's right, atoms. So, atoms, as we know, are particles, and they're very, very small. They're actually so small that they're invisible, even though they make up all of the everything around us. So, the atomic theory was proposed by somebody by the name of John Dalton. And I'm going to read what the atomic theory stated. The theory that all matter is made up of tiny invisible particles, atoms. According to the modern version, the atoms of each element are effectively identical but differ from those of other elements, and unite to form compounds in fixed proportions. So what that means is all the elements on the periodic table are atoms, and they have the same components and are very similar, except as they gradually get bigger and have more of each of the components, they differ a little bit, and they're all used to make the compounds of Earth. Everything around us, the gases we breathe in and breathe out, that's all chemistry. The stuff we drink is chemistry. Water, that's chemistry, and that's a compound, it's a mixture of hydrogen and oxygen, H2O. So, more importantly, once we understand that atoms make up the everything surrounding us, we have to know the components of the atom, and that expands on the atomic theory. So, we know atoms are everywhere, and that's what makes up things. So like our skin is atoms of many things. Paper is atoms of many things together, and those are called macromolecules because it's a lot of them, so that's why we can see them. Like the stuff we breathe, they're not because it's invisible, but the stuff we can touch and see, there's many atoms, therefore an accumulation of many atoms makes them visible. So, atoms. Atoms have three major components, and they're all different, but they're all necessary for the atom, except one is actually optional. So, the first major component of the atom is a proton. A proton is what mainly gives the atom its mass. So 90% of close to 99% of the mass of an atom is in what we call the nucleus. So the nucleus, if you can imagine, is like a small circle. And that's the center of the atom. And in the nucleus, in its region, is protons. And each element on the periodic table has a distinct number of protons. No two elements have the same exact number. That is the only thing that makes the elements different. Some elements, if they change, can have the same number of, actually, I'm getting ahead of myself. But protons are very important because it contributes to the mass. And protons are in the nucleus. I'm going to draw a P right here in this circle. Next, another major component of the atom is what we call neutrons. Neutrons also contribute to the mass of the atom, and as we said earlier, 90 to 99% of the mass is in the nucleus. So number 2 is neutrons. That also is in the nucleus. So, but it's optional. So not all atoms or elements on the periodic table have neutrons. And they can have as many as they really want. Because other than mass, it doesn't play a major role unless the number of neutrons are changed in the atom. Like whether it's a reaction or sometimes if elements get hit with radiation, they can change and they're altered, and that's not basic chemistry, that's more advanced. So neutrons are also in the center of the atom, but are optional. So just because there's an atom, that does not mean there are neutrons. And last, probably the most or second most important part of the atom, and this is all part of the atomic theory, electrons. So electrons are very special. They deal a lot with bonding, and they deal a lot with the way things react to one another. And that's why it's extremely important to understand electrons and where they are. So what's very interesting about the atom, so there's the nucleus, and that's the center. That's where a majority of all the mass is. And then surrounding the nucleus is where the electrons are. So if you can imagine, inside this atom, this will be the whole atom. So that's to show you where the atom is structurally. So the center is the nucleus. It's very dense. Surrounding that is the electrons. And the electrons on the periodic table, depending on the element, is always identical to the number of protons, unless there's a reaction or something happens to it or it's changed. But every element on the periodic table has equal number of protons and electrons unless it's in a reaction. So on the periodic table, P's, protons, equals E's. Now that is not an equation, that is just a reference, a guide, so you understand. If you know that a certain element has a certain number of protons, if it's on the periodic table and not changed, it hasn't reacted or bonded, the number of protons is always equal to the number of electrons. But what's cool about electrons is they have certain zones or regions to where they are around the nucleus. So electrons are not in the nucleus, they surround the nucleus, but they're not just floating around. They're not wherever they want. They're not free to flow or move around wherever they want in the atom. They orbit the atom. Do you guys know what orbiting means? Does anyone want to take a shot in the dark? That means to essentially be on track around something. So, for instance, the solar system. I have a picture of the solar system, as you can see right here. The solar system is about the planets. And the planets, they all rotate, which is different, but they revolve or orbit around the sun. So So as you can see, the sun's in the middle. The sun is in the middle, and the planets, such as Earth, go around it. They go around it, almost following like a track. Some go up. Some have a very longer. Some have a longer track, or one that's quite bigger. Some that take days or thousands of years to do, but they orbit around the sun, and that's just like the electrons inside of the atom around the nucleus. So, another thing, the way elements are structured, they orbit in rings, like a track, but the rings have an order. So if you look at the periodic table, the first row has one orbital ring. Some people call it the valence ring or outer shell. And it goes by the tiers of the periodic table. So row 1, hydrogen, helium. They only have one shell, orbital shell. So, for instance, around the nucleus, this is just the structure, so don't be thrown off by that. This is the first orbital shell. And that's where the electrons are. They're constantly moving. They're going very fast, orbiting it, bam, 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 circling it. But, remember like we said, the first two elements share the first orbital shell. So nothing else on the periodic table, no other row has only one shell. They have to have more. So the second tier, where it starts with lithium, that begins the second orbital shell. And P is always equal to E. Remember that. Protons is electrons, same number. And it's important to know, even if you didn't know that only the first row had only one ring, orbital shell, the first ring can only have up to 2 electrons. So, as you can see here, I'm drawing one dot. And this protons, neutrons, that's the nucleus, one shell, and one dot. So that would represent hydrogen, because you have we'll have a proton count. We'll do hydrogen, 1 proton, and there's no neutrons in hydrogen because they're optional. And 1 electron because P is always equal to E. So that's what a hydrogen atom, according to the way the atomic theory works, would be drawn. Helium, second one, remember the first shell can only have 2, would be like this. And you can draw them wherever you want, because this is part of the activity what we'll be going over later. It can have 2. That's considered a full shell because the first shell can only have 2. And that's helium. It's got its shell full, and as you can see, it's all the way on the right, which means the outermost shell is full. So all these have a full outer shell, but as you progress, there's more shells depending on the complexity of the atom and the row it is in. So, over here we're going to do lithium. Lithium has 3 protons, so we're going to do, the proton count is 3. So that means it has to have 3 electrons, but we begin the new shell. So that's the nucleus. This is the first shell. It has 1, 2, because it's full, and then it begins the second orbital shell, and it only has 3 protons. So we have 1 and 2, so we can put the last proton on the second orbital shell wherever we want. I'm going to pick right here. It's a great spot. It's one of the best spots there is, actually. Not actually. But that's what lithium would look like. We got the protons in the center, and the 3 electrons in the orbital shells that surround the nucleus. And that's one of the major key components of the atomic theory. It's that the electrons orbit the nucleus in the orbitals, and that's where the electrons are. And the first shell has 2, and the rest of the shells have 8. So, if you guys have any questions or you need help understanding this more, don't be afraid to ask. And for the next part, what we're going to do is, I'm going to put some questions on the board, and I want you to answer them by yourself. We're not working together yet. And answer them. The first one is going to be written, and the second one is, I'm going to write out an element name, and I'll even tell you which one on the periodic table is, and I'm going to want you to draw it how I drew it. So I'm going to go over another example. So we know this was helium. I'm going to change it to, let's say, carbon. So carbon has another shell because it's in the second row. And carbon, as you can see on the periodic table, is, who can tell me how many protons there are in carbon? Correct, 6. So we have the first shell full at 2 because there cannot be more than 2. And as I stated earlier, the second and the rest of the shells can have 8. So carbon is 6. So how many go in the second shell, everybody? That's right, 4. 4 electrons go in the outer shell. And like I said, you could draw them close together. You could draw them wherever you want here. We'll do, that's 2, 3, 4. 4 plus 2 is 6. Carbon has 6 protons. And if you look at it, it has 6 neutrons. We'll get into that later. So that is what carbon would look like. I'm sorry it's messy. We had a board malfunction. It's just these markers aren't good on the whiteboard. So we're going to go over another example. I'm going to tell you the element. You're going to draw it, and just like this. But before we do that, we have to know the neutrons. The neutrons contribute to the mass, and so does protons. Protons weigh 1 mass unit. Neutrons also weigh 1. So that's how we can tell the mass. Because electrons, yes, they do have mass, but it does not majorly contribute to the overall mass of the atom, especially not with the elements we're dealing with. So, if you don't know how many neutrons there are, you subtract the number of protons, the number of the order in the periodic table. So hydrogen has 1, helium has 2, lithium has 3, beryllium 4. So that means the protons. And you take the mass, subtract the protons. That tells you if you have neutrons. So hydrogen, if you can see, hydrogen has a mass of 1.008. So we know a proton weighs 1, and neutrons weigh 1, and they're optional. So we know the mass of hydrogen is 1. And we know that a proton weighs 1. So you subtract that, and how many neutrons on there? 0. And to show you a better example, helium. Helium weighs approximately 4. But how many protons are there? Because it's the second element, there's 2. So you subtract that. There's 2 neutrons in the nucleus of a helium. So, with the atom I choose, make sure you tell me how many protons are in the center, that's the order, and then how many neutrons. Subtract the mass, subtract the proton count from the mass, that's the number of neutrons, and then tell me how many shells it has. So remember, hydrogen and helium only have 1, and there can only be 2. The next row is a new ring, the third row, new ring, and those can have up to 8. So work on that, and if you have any questions, I'll be here. If you need help with anything, feel free to ask, and we will take it from there.